We applied the loading condition in last video, one of the edge fixed, and we have applied the displacement given in the problem statement on this vertex. Now let's solve this. You can press F5 or you can press solve button here on the top context menu. So solution is done. It's very small problem, it won't take that much. If you are interested in looking at how much time it has taken, you can go to solution output. Instead of solver output, you can put solution statistics. So it just take a 2 seconds to solve this problem, right? Now let's fetch the result. We'll first take the total deformation. I'll click on total deformation and we'll say evaluate all results. So deformation is 0.00022 mm at this vertex. It's going down. You can play the animation. So it's, if I'm fetching it down, so it will deform like this. So this exaggerated scale 9600 times scaled because it's very small deformation and won't be able to see from the true scale or naked eye. Now let's find out the results which is asked in the problem statement. We have to find out the stresses in all the stresses components and strain component. Let's first find out the stress component. So you can right click here, insert stress, and you can go for normal, or from the context menu you can go for normal stress here. We'll call the normal stress in x-axis. Make sure that it is not average across the bodies. So it's one element, so that's not affecting here. So 1.5 megapascal stress in x direction. I will right click and I will say rename based on definition. So x-axis normal stress it will give. I will right click and will say duplicate without results and will change the orientation to y-axis. So we got the y-axis and we'll say rename based on definition. Right, so it's 0.45 megapascal. Now let's fetch the shear stress. You can right click, duplicate, and change the normal stress for shear stress, or from here you can call the stress and shear stress. So this is a shear stress. Shear stress value will be xy because it's 2D problem. So this will be tau xy. I will say rename based on definition, xy component of shear stress. So it's approximately 0.299, that is 0.3. So we have completed the stress results. Now let's look at the strain results similar way. We'll go to the strain, normal strain, x-axis strain, I will rename based on definition. We'll right click and say duplicate without result. I will fetch for y-axis results. I'll say rename based on definition and we'll say evaluate this. So it's in y-axis strain is not much. I will now ask for shear strain. In strain I will say shear strain along the xy. Evaluate this result and I will say rename based on definition. So it's minus 3.71 into 10 to the power minus 6. So we have completed the post processing of this. As it is one element, you don't have the legend which is colored in a different way, and also the value is a single value for the single element in the nodes. Now next is we are going to compare the result of this and by hand, also how we can evaluate this using CST methodology, constant strain triangular methodology. So what's constant strain triangular methodology, that we are going to see in the next lecture. Also we are going to compare the results which is derived from the answers with the hand solved FEM problem.